Molecular compounds are compounds that are made of non-metals. And we are going to specifically look at what are known as binary molecular compounds. Now, ionic compounds can be binary as well. Binary simply means we're looking at two different elements. So we're going to focus on binary molecular compounds. So here's an example right here, two different elements, and they're both nonmetals. So when we're naming binary molecular compounds, the first element in the formula is named as its elemental name. So if we're looking at this example, capital S, capital O, subscript 3, sulfur. The second element retains its root and ends in "ide," oxide. And then we use Greek prefixes to tell how many of each atom are in the molecule, except we don't use mono for the first element. So this would be sulfur trioxide. Molecular compounds are held together by covalent bonds, which means they're not canceling out charges of oppositely charged ions. So we don't always know what the combinations are going to be. For example, there are half a dozen compounds that form between nitrogen and oxygen. So we use the Greek prefixes to let us know how many atoms are in a molecule. And this is table 4.4 in your text, and it reviews what the Greek prefixes are: mono, one, di, two, etc. Now, as I mentioned earlier, we do not use mono for the first element, but we do use it for the second element. Okay, so CO, capital C, capital O, would be carbon monoxide. Capital N, capital O would be nitrogen monoxide. Even though there's one of each atom in that molecule, we only use the term mono for the second, and we always use it for the second. Alrighty, so another thing to keep in mind is when there is an A and an O together, or two O's together, then we get rid of one of those vowels. So here the slide says we get rid of the not sure what we get rid of because I just moved it. Let's see if I can get that back. Silly Miss P. It looks like it wants us to remove the O, but really what I've seen previous is the A. But anyway, we don't have two O's or an A and an O together. We get rid of them. So this would be tetraphosphorus decoxide, this molecular compound right here. Now, if we look at binary compounds that are made up of carbon and hydrogen, they follow a different set of rules that are beyond the scope of this class. And binary compounds with hydrogen never follow the rules. Now, there are three binary molecular compounds whose common names you need to know. H2O is water. It's never dihydrogen monoxide. Ever. H2O is water. NH3 is ammonia. And H2O2 is hydrogen peroxide. You will need to know those.